What's up, class? It's Martin Tellez, and I am coming to you from my bed right now. I am not feeling too good, so I'm hoping to get through this. Um, it's a distributed array radio telescope, which is DART, and this is the telescope I've chosen to do my presentation on for the activity, the telescope activity. Here's some DART tiles here that I found. And DART consists of 48 dual polarization dipole antennas optimized for the 80-300 frequency range. And this is at Embry-Riddle Aeronautical University here in Prescott, Arizona. So I'm going to the next slide here. The array has no moving parts, and all telescope functions, including pointing, are performed by electrical manipulation of dipole signals. Each tile performs an analog beam-forming operation, narrowing the field of view to a fully steerable above 30 degrees. So this telescope helps the space physics and technical intelligence fields of study there, Embry-Riddle over in Prescott, and it supports their astronomy program. Provides integration of real-time astrophysics data into the classroom instruction and labs, and it allows the students to steer the telescope to observe astronomical objects from their own computers. So it's a bunch of different telescopes, all for one, that they use there. Pulsar detection and timing is the primary science goal of the DART telescope, and it provides pulsar timing information in the form of pulsar anomalies to LIGO, and it provides a capability for students to use the phased array telescope to observe many astronomical objects. I can't really find when this telescope started. There's not a lot of information on that. I do though in the future they're going to use it to detect redshifted emissions from the EOR and all sky surveys for radio transient sources. And it's also going to investigate the heliosphere through scintillation and Faraday rotation. So that's a lot of words that are kind of beyond me right now at the moment, but hopefully all you understand out there. Thank you for watching my presentation, and I got through it. Here are the two references that I used for the pictures and the images and what I read. And I will see you on the next mission. Thank you.